Hi, welcome back to the second part of our demo. In this part, we're going to switch our viewpoint from the one of data scientist into the machine learning DevOps one. I'm going to show here how Kubeflow can be used to turn the model developed by the data scientist into a real-time web application, how it can be used to deploy this web application to the underlying Kubernetes cluster, um, and how we can expose the endpoint of this application for model serving. And later I will also sketch a few strategies on how these machine learning products can be tested in Kubeflow. Before we start, I would like to stress that many, if not all, the steps that I'm going to cover in this part can be made fully automatic. But for the full automation, one would need also other tools next to Kubeflow. So for the sake of simplicity, I'm going to execute them piece by piece in a manual mode. All right. So the very first thing I need to do is to get the deployment version of the code base from the data scientist. So I can go to VC, to the version control, and check the latest commit. Here I see the commit from the data scientist, also telling me which workspace I should use to deploy. So in my Jupyter Lab environment, I can just simply git pull. Okay, so my directory seemed to be up to date, so I can continue. The next step is to build the machine learning product. This means to inject the model into a model serving framework. There are generally two strategies on how to serve models in Kubeflow. The first is to package this model into a dedicated Docker image and roll it out to Kubernetes in the form of a Kubernetes pod. You can think of a pod as a dedicated server. This strategy is implemented by Kubeflow module called fairing, and this is what I'm going to show today. The second strategy is the serverless way, called Kubeflow serving. Under the hood, Kubeflow has its own application server to which you can send your model file. We are not going to present today how to deploy model using KF serving. This would be for another presentation. Both of the serving strategies have their advantages and disadvantages. For this demo, I've chosen fairing because when you build your own server, you have more freedom on the implementation, which is handy in this case when we are deploying a credit scorecard, which is by far not a typical use case for Kubeflow. Similar to the Kubeflow pipelines, there is also Kubeflow fairing Python client so that you can deploy the model directly from your notebook. Let me now open the pipeline notebook created by the data scientist and continue working directly with this notebook. The great advantage of this way of working is that I can reuse the training codes and functions defined by the data scientist. This way, I do not need to refactor any business-related logic, which is great because this used to be the bottleneck and also the source of implementation errors. In order to deploy model using fairing, you need to stick to certain Kubeflow way of doing things. You have to create a deployment class that acts as an interface to the backend, and this class has to implement two methods. The train method, which is here, and the predict method. The train method, this one, is there to retrain the model if needed. In this example, we, however, trained the model already in the training pipeline. Nevertheless, for the sake of illustration, I show here how this method can be implemented. Note that I'm basically using the same functions defined in my training pipeline above. So I'm really recycling the code of the data scientist. The next method, the predict method, is there to serve requests incoming from the API or coming to the API and then passed downstream. This is where the model is used to ingest data and return credit scores. Let me now run my code. So I will import and run the function. And finally, I can do a quick test of whether my fairing class is working. So I'll just initiate the object and I will read some data from a file and send them towards the predict method and see what it gives. Okay, so here you can see that I send in some data and I got an array of scores back. So the fairing class seems to work fine. Once I have my fairing class working properly, I'm ready to build and deploy my machine learning product. Note that the first deployment should be a test deployment, meaning that the app should end up on a testing cluster. Only after the app is properly tested, it should be redeployed to a production cluster. In order to build my app, I need to configure the backend side for my deployment. So that's this part of the code. And here I'm basically configuring which cloud I'm using as a backend, which container registry I use to store my Docker images containing my model, and so on. The actual build and deploy process is streamlined by Kubeflow for me. And for me, the process boils down to specifying these few lines of the code where I specify which fairing class I want to use to create the endpoint, what are the input files that I want to inject to the Docker container. And here note that since I know the workspace version from my commit, I can go back to the Kubeflow artifacts and I can check the exact version. For instance, for my model, I can check the exact version that I want to deploy. And then also I need to specify the base container image. So that's basically a container image to which I am going to inject the input files and on the top of which I'm going to build the web app. Then I can execute the prediction endpoint creation code. And there are, as we speak, the endpoint is being built. And there are quite some things happening behind the curtain. So for instance, the base image is being downloaded from the container registry. My model is injected into this image. The model is then wrapped into a Flask application and its endpoint is presented to the user. That's actually happening now. And the endpoint is basically a web address where my model will be waiting for the incoming requests. And here we go. This is basically the endpoint. This is the web address. As I mentioned previously, only properly tested machine learning products should be deployed into the production cluster. By the way, there is a nice article by Martin Fowler on how a full-blown acceptance testing pyramid should look in this kind of MLOps setup. And Kubeflow is not, and as far as I'm concerned, it does not even have the ambition to become a fully fledged test framework. This being said, it does not mean that you cannot test anything at all. So let me show you now what are the things that you can test. The first thing that you can do a real quick test of is your endpoint. So once your endpoint has been created, you can read in some data, and with this one-liner, you can just send the data towards the endpoint. And you see that you got the response. So the important thing here is now we are not sending a data to a model that is living inside of this notebook. We are actually sending the data through a wire to an endpoint that is existing somewhere in the Kubernetes cluster, and we are getting back the response from this model. Another thing you can do is you can create some kind of acceptance testing pipeline. And here you could again use the Kubeflow pipelines. So I here just prepare an example of how this could look. For instance, you can create a data unit test in which you will test the data interface. So basically you are testing whether all of the columns that should be there for the model to work properly, if they are there. And here I'm not using anything special. It's just the Kubeflow pipeline and the unit test framework of Python. And I created a couple of unit tests, testing whether the target column is in my model for training, whether there is age, the credit amount, and the duration. So these are the columns of my input data. And similarly, I can do also so-called contract tests. So that's basically the test that the model is injected correctly and is working correctly with the API that is feeding this model. And here I can just do a simple test that I load in some data and I will send the data to the API. So something similar that we did previously manually. Here I can wrap it in a test case. And so now when I just run this pipeline from the top till the end, I can go to the run link. And I see that the tests are being carried out by the Kubeflow pipeline. I can check in the logs, and for instance here I see that my 4 tests run and they all ended up fine. So, and the contract test is also okay. So this is just a sketch on how you can do some kind of acceptance testing. The important point here is that you cannot test everything, obviously, with Kubeflow, but you can do a lot. And the more of these tests you create, and the more of these tests you hook up to your model deployment workflow, the higher the chance that the deployment process will be stable. All right, and now that our model is deployed and it is tested properly, the very last step of this process would be to deploy it to a production cluster. So basically carry out the same set of steps, but in the last step, here we deployed it into a default cluster. And here you can, for instance, if you would have another Kubernetes cluster that would be used for productions, you can just here change the host. I don't have such a cluster here, but you can just write a host of that cluster. Here comes your host. And if you would run this code with your host address, then the model would be now deployed into your production cluster.